statement, an if-then statement to start off with. You're not shooting here. Can we, I keep using the dogs in heaven one, maybe we need another one. If it rains, of course. Okay, if it rains, it pours, that's fine. That's nice and short, so since I'm writing this a bunch, this being short is important. If it rains, then it pours. Okay, so this is our original statement. This is called a conditional statement because the first part is the condition for the second part to happen, right? Like this condition needs to be met and then this happens. So anyway, that's a conditional statement. That's just the starting statement. It's an if-then statement. Okay, let's do, I think, converse next. The converse of this statement is when you switch the two parts of the statement. So if it's pouring, I don't know if this is the best sentence to use, but if it is pouring, comma, then it is raining. Okay.
So it's just the opposite.
So you switch the if and the then parts. So if this happens, then this happens. Now, is that all? Oh, I know what I always use. Maybe I should change it real quick. Because this is kind of a good example. If it is a mammal, then it has hair. Okay, so what would the converse of that statement? Okay. Now, is the original statement true?
Yes.
Yeah, it's supposed to be. Somebody said like hairless cats, I don't know. Maybe the whiskers can, if it's like genetically modified, maybe not, but normally that should be true. If it has hair, is it a mammal?
No.
What has hair that's not a mammal? We need counterexamples. Spiders, peaches. I'm not sure peach fuzz would count as hair, but spiders, some bugs have hair. Is there anything else besides bugs that I can think of?
Technically whales.
Whales are mammals.
Oh gosh.
And dolphins. They breathe air, they have live babies. I guess they have a little hair, I don't know. Okay, converse. Okay, inverse is next. So these two are not logically equivalent. This statement was true and this statement is false. So saying it in opposite order is a different meaning. If you are a junior, then you're in high school. True. If you're in high school, then you're a junior. Not true. So those are not logically equivalent statements. Inverse. Okay, the inverse is where you negate both parts of the sentence. So if it is not a mammal, we're going to be writing a lot of sentences today. So
Ooh, yay.
it is
English class.
not,
Let's go.
it does not have hair. Okay, is that true? If it's not a mammal, then it does not have hair. No, not true. It's kind of like this. these two are actually kind of saying the same thing. If it's not a mammal, like a spider, it doesn't have hair, not true. So these two are actually logically, they won't ask you this, but they are logically equivalent. They're saying the same thing backward in a different way. Okay, and then the very last thing is contrapositive. Is it possible for a sentence and its converse to both be true or both false? It actually is. A lot of definitions, like if it's a right angle, then it's 90 degrees. If it's 90 degrees, then it's a right angle. So those are both true. Contrapositive is where, so it's the biggest word and it's where you do both. So you switch the order and you negate them both. So what did I start with? So this is going to come first and it's going to be negated. If it doesn't have hair, or if the animal doesn't have hair, or whatever, if it doesn't have hair, then it's not a mammal. Is that true or false?
True.
That is true. A contrapositive is logically equivalent to the original statement. It's saying the same thing kind of backwards. If it's a mammal, then it has hair is kind of like saying if it doesn't have hair, then it can't be a mammal. The box, right? All right, does that make sense? So, let me zoom out a little bit. These two go together, like they're saying the same thing backwards. These two actually go together too. If you look carefully, these are contrapositives of each other. These two are. But anyway, you don't really have to know that part. But these two do not necessarily match the original statement. If this is true, these may or may not be true. If this is true, this one has to be true. If this one's false, this one has to be false. Okay, got it? Sure. Oh, and the symbols look like this. Like, let's say A is, it's a mammal, B is, it has hair. And the way you write that with symbols is just like this. If it's a mammal, then it has hair. So just that arrow implies it's an if-then statement. If this happens, then this will happen. All right, does that make sense? So on, was it Friday we did this? Yeah, the one we just graded? No, that was, yeah. This means negate the statement. You guys remember that?
Yes.
What did this mean? Sometimes. Let's see, what about this one? All the time. So this would be like some animals are mammals, all animals are mammals, something like that. No animals are mammals. Okay, anyways, this is kind of the new symbol for today, this thing. All right. Okay, biconditional, this I think is our last definition. So, if it works both directions, then you can say it's biconditional. Like, if this first part is true, the second part is true. If the second part is true, the first part is true. Like they're connected both ways. It's called a biconditional, and the two parts of the statement, listen, are connected with if and only if. So, my example that I created was if it's a 90-degree angle, then it's right. Or if it's a right angle, then it's 90 degrees. So that is true both ways. Most definitions work like, or all definitions work like that. So they could be connected with if and only if. That means they go both ways. So an angle is 90 degrees. So notice I didn't start off with if on this one. If and only if it is a right angle. Okay. So 90 degrees happens when it's right angles happen when it's 90 degrees. Goes both directions. This implies if an angle is 90 degrees, then it's a right angle, and it implies if it's a right angle, it will be 90 degrees. All right. So this is the key phrase. No, notice there's no if at the front and there's no then here. It's no longer an if then, but the two parts are connected with if and only if. So if I said, well, this is not true, but let me think of one that's true. If you are a carnivore, then you eat meat. If you eat meat, then you're a carnivore, right? So that could be written as one sentence. An animal is a carnivore if and only if it eats meat. Right. Okay. Number one, here, ready? Lots of sentences, starting on number one. Write each statement in if-then form. So you kind of have to be careful of the order. Which part is the condition and which part is the outcome? When I study, I get good grades. What would that be as an if-then statement? If I study, then I get good grades. So that's number one. Okay. A square is not a triangle. How do we write that? With the shape?
Is a triangle, it's not a square?
No, other way. A square is not a triangle. So if it's a square, it can't be a triangle. That's what they're saying. So if the shape is a square, then it is not a triangle. The order does matter. Skew lines are not in the same plane. Now, I think number two is the only one that the order is backwards now that I look at it. Yeah. Because when it snows, so going sledding is dependent on if it snows or not, on number two. So on number five, skew lines are not in the same plane. So if lines are skew, then they are not in the same plane. All right, and then we're skipping to, let's see, number 12, 13, I guess. Write the converse. So do you guys remember what did converse mean?
It's kind of like the not negative.
Okay, that's when the order switches. So the if part becomes the then. So you do if of the second part, then of the first part. So instead of if all people have sinned, then all people need a savior, it's going to be if all people need a savior, then all people have sinned. Did they capitalize savior?
Yeah.
IOUR? I think it has two spellings. this one just has a O, right? Okay, if all the people need a savior, then all people are saved. How would you know that the U is the British spelling?
Because they like to put U's in words like color.
Alright, 15, no, shoot, I'm on the wrong one. That's 13 and now we're on 15. Skipping the second section. Oh. Well, I said O because actually we did want to do number 11. So we'll go ahead and do number 11 after number 13. Dadgummit. Okay, 11. So, given R then S, write each related statement in symbolic notation. Okay, so the original statement is if R then S. So what would the converse of this statement be?
SR.
Yeah, if S then R. That's B, or that's A. B, what's the inverse of this statement? So you negate this one and you negate that one. So the inverse is if not R, then not S. So we're using the symbols from Friday. What's the contrapositive? Do you guys remember what I said that one was? You switch the order and you negate. So you do both. So it's if not S, then not R. And this is, it's actually logically equivalent to the original statement. Okay, D, right, the biconditional. So I never mentioned this symbol. Biconditional means it works both ways, so you do a little double arrow like that. Okay. E, we're going to skip the equivalent disjunction. There's a way to write that as an or statement, but not too important. Okay. Now back to number 15. Back to the sentences. That was 11. 15. If two lines do not intersect, then they are parallel. So we're going to switch the order. If two lines are parallel, so I'm moving the subject, the two lines, so because it sounds better. If two lines are parallel, then they do not intersect. You guys see how I did that? I'm not going to put if they are parallel, then two lines do not intersect. Okay, that kind of makes sense, but it sounds better if you put two lines in the first clause. So if two lines are parallel, then they don't intersect. Oh boy. All right, write each biconditional as a conjunction of two conditionals. Do you guys remember what the word conjunction meant? And. So, it kind of sounds like they want us to run on sentence, actually, but we'll just write two different sentences. Let's see how they wrote 17. Yeah, they did. They did one giant run-on sentence with a semicolon. No. We'll just write it as two sentences. Okay, 17. You will go to heaven if and only if you are saved. So that implies, we're going to write what that implies. If you go to heaven, then you have been saved, or if you are saved, then you will go to heaven. So you got to say it both ways. So lots of sentences. So the if and only if, call it biconditional, it implies that it works both directions, and basically we're just writing the sentence as an if-then statement in both directions. Uno mas of this section. A figure is a regular polygon if and only if, you guys remember the regular polygon definition? Equal sides and equal angles. So equilateral and equiangular. If a polygon is regular, angular. Alright, 21, 23, 29, 31. 21. Oof, oof. Got a lot said. Write the converse and the biconditional. And state whether the original, the converse, and the biconditional are true or false. Okay, so there's two sentences we gotta write and then three true or falses. Okay, so the original statement, if an animal has four legs, then it is a cow. So the converse, what did that mean? Switch the order. If an animal is a cow, then it has four legs. Okay, that's the converse. How do I write the biconditional? So I'm going to connect the two parts with if and only if. I'm dropping off the if and then if at the beginning. So an animal is a cow if and only if. It has four legs. So this is the converse, just to be clear. Switch the order of their statement. And this one's the biconditional. So there's three true or falses. Is the original statement true or false? If an animal has four legs, it is a cow. False. Okay, second sentence. If an animal is a cow, then it has four legs.
True.
True. Usually I get a comment here like, what if it's lost a leg or is deformed? And they kick me out of class. All right, the last one. An animal is a cow if and only if it has four legs.
False.
False. Okay, this is implying that these two will always go together. Four legs does not imply a cow, so it's false. Basically, if these are not both true, this is not going to be true. Because a biconditional is saying the statement and its converse are true. So if they're not both true, the biconditional is not true. Okay. Another one. 23. If 3x equals negative 12, then x equals negative 4. So if I switch the order, if, for the converse, if x equals negative 4, then what was it, 3x equals negative 12? And the biconditional, x equals 3x equals negative 12 if and only if x equals all right. So is the original statement true? 3x equals negative 12 and x equals negative 4. That is true. Solve for x. So is the second statement, this converse, true? If x is negative 4, then 3x equals negative 12. False. No, that's true. If x is negative 4, this would equal negative 12. True. So is the contrapositive true or false? True. Works both directions. All right. Last section. Write the inverse. Okay, we haven't done inverse yet. What was inverse? Was it 29? Yep. Inverse is where you negate both parts of the sentence. So if two angles have the same measure, it becomes if two angles don't have the same measure, then they are not congruent. This one's then we're supposed to write the contrapositive to their original statement. So we're gonna switch the order and negate both. So if two angles aren't congruent, then they don't have the same measure. Oof. So I hope you go. Last one. If two lines intersect, then their intersection is exactly 1 point. So the inverse is where we negate. If two lines don't intersect, then they don't, then their intersection is not 1 point. That one kind of doesn't make sense. Let's see how they wrote it. Is not exactly 1 point. So, yeah, just make them, inverse makes them negative. If it was already a negative, the inverse would make it positive. So don't and not, that makes it an inverse basically. Okay, and then the contrapositive is where we negate and switch the order. So these are already negated, it's just this one is gonna go first. So if two lines intersection is not exactly 1 point, computer's dying. They don't intersect. Oof. Any questions on that? Inverse, or, well, usually the order is converse, inverse, contrapositive, and then the biconditional is the if and only if one.